This is Anomaflow, a Beam pipeline that applies anomaly detection to the cybersecurity domain. The problem: detecting anomalies in large volumes of telemetry data from Bindplane collectors in real time is difficult and often delayed. Who is affected and why it matters? Security teams risk missing early cyber threats, leading to potential data breaches and downtime. What makes this solution different? Anomaflow uses Apache Beam on Google Cloud Dataflow to process streaming telemetry with scalable, low-latency anomaly detection tailored for cybersecurity. The solution was built in Python using the latest version of the Apache Beam SDK, Terraform, OpenTelemetry, and several resources and services from Google Cloud, including Dataflow, Google Cloud Storage, Google Cloud Engine, etc. Key challenges and solutions. Parsing OpenTelemetry data was not simple, but using sample files and local Beam runs helped accelerate debugging. On Google Cloud, setting up separate VPCs for Bindplane and Dataflow required fine-grained AIM and routing configuration, which Terraform helped automate. To handle streaming file uploads, the plan is to use Google Cloud Storage and PubSub notifications to trigger anomaly detection jobs dynamically. Unfortunately, we didn't have time to implement it for this demo. Architecture. We have two VPCs on networks. The anomaly detection VPC is used by Dataflow to host the ephemeral masters and workers that run our Apache Beam jobs. The Bindplane VPC is for running the Bindplane agent that collects metrics from its host and sends those to the telemetry Google Cloud bucket. In this network, we also have the Bindplane server that allows us to configure and monitor the agents, among other things. Are you curious about the collector and what it's sending? Let's take a look. This is the Bindplane server web UI. You can see we have just one agent or collector, but in a real scenario we would have many. This collector is configured to send metrics from the host to two destinations: DevNull, which is used just for testing, and our telemetry Google Cloud Storage bucket. We receive all this telemetry as JSON files in the bucket. I will now execute the pipeline so you can see the detection logic in action. As I said, on-demand processing is not implemented yet, so I will execute the pipeline in batch mode from my own local machine. Although I'm using the local runner, the pipeline will read from and write to the bucket on Google Cloud. It will read the telemetry data files from the input folder, and any anomalies it detects will be written to the output folder. You can see the pipeline found one anomaly. Let's go back to the bucket to see the resulting file. You can see the one anomaly detected. What we achieved: we built end-to-end anomaly detection pipeline using Apache Beam on Google Cloud. We successfully parsed and processed OpenTelemetry files from Bindplane collectors. We detect anomalies and export the results to Google Cloud Storage, while the infrastructure was deployed using Terraform. For next steps, we'd like to improve the pipeline to work with Google Cloud Storage notifications via PubSub and export anomalies to BigQuery for analysis. We'd like to improve the anomaly detection logic using statistical models or machine learning. It would also be interesting to add alerting and visualization through cloud monitoring or Grafana. Do love your suggestions, especially on the detection logic. Thank you.